Okay, so for the next step, we're going to look at some of the so-called double angle formulas. And what they allow you to do is, as you can see from the formulas here, they let you take something that has 2 theta in it and turn it into an expression with just theta. So on the left-hand side here we have 2 theta, and here we have just thetas. And how can we derive these formulas? They follow from the addition, subtraction formulas. And as a small sidetrack, basically anything in trigonometry, in this course at least, follows from the addition subtraction formulas. Those formulas are very powerful, but as you've seen, they're also a bit low level, so that's why we have these more specialized formulas, because they're easier to use in specific circumstances. So let's look at the first two together, and then the third one I will ask you to check this by yourself. But you'll see that the principle is entirely the same. So for the first one, we start with the left-hand side, sine 2 theta, and we write this as sine theta plus theta. And now we apply the addition subtraction formula, sine theta cosine theta plus cosine sine. Those two terms are of course the same, so this becomes 2 times sine theta cosine theta, and that gives us our formula 1. And then for the second one, cosine 2 theta, we do the same thing, cosine theta plus theta. We apply the appropriate addition subtraction formula. Now it's cosine cosine minus sine sine, and if we clean this up a little bit, this becomes cosine squared theta minus sine squared theta. That's enough to give us what's on the slide, but there's two alternative forms that we can derive. So what we'll do is we'll start from this, and we'll do two separate changes. We'll make two separate changes to the formula. So for the first, we'll use the fact that cosine squared theta is 1 minus sine squared theta by the fundamental identity. Remember, sine squared plus cosine squared is always equal to 1. So if we plug that into the equation, what we get is that the expression becomes 1 minus 2 sine squared theta. On the other hand, we can also take sine squared theta and write it as 1 minus cosine squared theta. And then if we plug that expression into what we had previously, we get that this becomes 2 times cosine squared theta minus 1. So in fact, we get 3 formulas for the price of 1. And let me write them down below here. So formula 2 prime is cosine 2 theta is cosine squared theta minus sine squared theta, but this is also equal to 1 minus 2 times sine squared theta, and that's also equal to 2 times cosine squared theta minus 1. And depending on the circumstances, sometimes one of these expressions is easier to use than the other. So let's work out a small example together. Let's prove that cosine 3 of x is equal to, cosine 3 times x, is equal to 4 times cosine to the power 3, cosine cubed, minus 3 times cosine of x. This is also known as the triple angle formula, because there's a 3 in the cosine. So we don't know how to take 3 times an angle, but we know how to take 2 times an angle. So let's see if we can get to a point where we can use our double angle formulas. And let's write cosine 3 of x as cosine 2 times x plus x. And now we use the addition subtraction formulas again. It's cosine 2x cosine x minus sine 2x sine x. And now we're in a good position to use the double angle formulas. So we can write this as 2 times cosine squared x minus 1 cosine x minus 1 minus 2 times cosine squared x. Sorry, that's wrong. Minus 2 times sine x cosine x times sine x. Work this out to get already 2 times cosine to the power 3 minus cosine of x minus 2 times sine squared x cosine x. We're not there yet. We have this sine squared of x here. So what we're going to do is we'll write this as 1 minus cosine squared of x. And for the sake of clarity, let me write out what this entire expression is again. Cosine to the third minus cosine x minus 2 times cosine x, and then plus 2 times cosine to the third x. So you multiply cosine x times what's in parentheses here. Now if you clean this up a little bit, you get 4 times cosine to the power 3x minus 3 times cosine x. So next up is the half angle formulas. So the half angle formulas here, what you do is you go in the opposite direction. You have something that has theta, and you turn it into something that has theta over 2. And by yourself, you sort of think like, why would you do that? Why would you complicate it if we just use double angle formulas? But what you can also do is you can take theta over 2 here, and then turn that into theta. So you basically go back and forth between the angle and half of the angle, or double the angle. The derivation of these formulas is not so complicated. So the derivation actually starts with one of the double angle formulas. So we take the formula for cosine 2 theta, and there were 2 alternative expressions. On the one hand, we had that cosine 2 of theta is 2 times cosine squared of theta minus 1. And so if you do some algebra, if you just manipulate these expressions and you bring cosine squared to the left-hand side, you can see that cosine squared is equal to 1 plus cosine 2 theta divided by 2. So that's for 1, and then for expression 2, we get that, or we can start from the other expression that we knew for cosine 2 theta, namely 1 minus 2 times sine squared of theta. And again, doing some algebra, if you bring sine squared theta to the left-hand side and put everything on the right-hand side, you get that this is equal to 1 minus cosine 2 theta divided by 2. And then the third one, of course, is not so difficult. Excuse me. If we start from tan squared theta, and we write it as sine squared theta cosine squared theta, and we use the results that we just obtained. Cosine 2 theta over 2, 1 plus cosine 2 theta over 2. Then the 2's in the denominator cancel out, and we're left with precisely the expression that we were after. So to finish this part up, we'll do one more example. So what I want to do is basically rewrite a given trigonometric expression. So write cosine squared x times sine squared of x, so that there are no powers of cosine or sine. So basically what I want to do is I want to get rid of these exponents in this expression, and I have to use my formulas to get there. And if we just skip back to this previous slide, the half-angle formulas are very good for that, because you can see on the left-hand side here we have powers, we have squares, and on the right-hand side we have no powers. So let's see if we can use that to our advantage. So we take cosine squared sine squared, and now we substitute what we know from the half-angle formulas. 2 times x divided by 2, 1 minus cosine 2x divided by 2. And now you can work out this algebraic expression, and what you will end up with is 1 divided by 4, 1 minus cosine squared 2x. And here, in order to make this transition, I basically used the rule for difference of squares. A plus b times a minus b is a squared minus b squared. So that's already good, but I still have a power here. So let me use my half-angle formulas one more time. So now I have 1/4, 1/4, and then cosine squared of 2 times x. That's 1 plus cosine 4 times x. So you always double the angle here, and then you divide by 2. So if we write this out now, we get 1/4 minus 1/8 minus 1/8 cosine 4x. 1/4 minus 1/8, that's 1/8. Or rather, let me write this directly as 1 minus cosine 4x divided by 8.